Alright, so in this video we're going to go through some revision notes for Physics 0625 Cambridge IGCSE for Topic 3, Forces and Matter. So let's begin. Force. What is a force? Force, by the definition in our syllabus, is a push or pull. A push or pull on an object due to interaction with another object. So that's the definition of force in our syllabus. But to understand force exactly, let's relate the definition to our natural phenomena. Because again, physics is a science of natural phenomena. Forces are applied almost everywhere in our daily life. When you're sitting down, you're applying force on your chair or on the platform you're sitting on by your body. Your body weight is applying force to that platform you're sitting on. It's applying contact force. There's contact force between. As you're walking, there's contact force between the floor and your legs. Your legs are pushing down, the floor pushes back up. This is the contact force. Gravity is pulling you down. There is force pulling you down. As you're running, there's kinetic force. There's kinetic energy that creates force. There's elastic force. As you're doing a skipping rope, there's elasticity between the ropes that's causing a force for the skipping rope to move. So forces are all around us. And because anytime you make any push or pull on an object, a force is applied. As you're driving your car, there is a force driving or pushing the car forward, which is known as the thrust force. There's friction force between the tires and the road. So there are forces all around us, okay? And they're used in our daily lives because, again, it's a push or pull, and we're pushing and pulling on objects all the time. Now that you've had a good basic idea of force, coming back to the syllabus. The SI unit of force is Newton, so forces are measured in Newton, and it's a vector quantity. Vector meaning it has both magnitude and direction. How do forces affect bodies? Forces can change the shape of the body. It can stretch it, compress it, or deform it. For example, a spring. A spring, when you apply forces on both sides of the spring, it changes the shape of the spring by compressing the spring. It can change directions, up, down, left, right. When you're driving a car and you move to the left, many forces are applied here. Force of gravity, force of friction, force of thrust. But all these forces cause the body, which is a car, to change its direction to the left. It can cause a change in speed. A forward force will cause acceleration and cause speeding up. A backward force is going to cause deceleration and cause speeding down. And the direction of these forces, since force is vector, it has direction, we represent them by arrows. So a big force is represented by a much longer arrow. A small force is represented by a small, tiny arrow. Let's list some common types of forces now mentioned in our syllabus. The first one is the gravitational force, or also known as weight. This is the pull of gravity on an object vertically downwards at the center of Earth. So the pull of gravity downwards vertically at the center of Earth. Okay? For example, I have an object here. I drop this object down. The object is going to fall down right at the center of Earth, or at its center, where its center is towards Earth, vertically downward. Why? Because gravity pulls it downward. The second one is the contact or reaction force. This is the push of the surface on an object perpendicular to the surface, and it prevents you from falling through the floor. Why? Because it pushes you to the surface, and the surface pushes you back. Weight is pushing you down, contact force pushes you back. So it helps you to stay balanced. Another type of force is tension force. Tension force is from a rope or a string on an object. For example, if you attach an apple to a string and you rotate the apple is going to be rotating continuously by the force you're applying on the string, and that string is applying a tension force to that apple, causing it to spin around. Other types of forces are magnetic force, electric force, elastic force, and nuclear force. Upthrust. This is the upward force of a liquid or gas on object. This is like the contact force, but in fluids. Because contact force is usually for solids, like for example, when you're standing on the floor, weight pushes down, contact force pushes you up, it keeps you balanced. Upthrust is like the contact force in fluids. So when you're swimming or when you're back floating in water, you're pushing, of course, gravity is the weight is pushing you down, and the upthrust of the liquid or fluid is pushing you back up. Like we see this person here who is swimming, the upthrust is helping this person to stay and float on the water. Another very common and very important force in our syllabus is the friction force. This is the force between rubbing two surfaces together. One surface, two surface, rubbing them together. Always acts on the opposite direction of motion. If motion is going forward, your friction is going to be backward. Motion is going left, friction is right, and so on. What does friction depends on? It depends on two main things, the speed and the surface. Faster the speed, more friction. Less the speed, less friction. It also depends on the surface. If there's a rough surface, there's going to be more friction. On smooth surface, since sliding or rubbing is easier on smooth surfaces, there's going to be less friction. Air resistance and drag. So like upthrust is the contact force in fluids and liquids. For the contact force, air resistance or drag is like the friction, but mainly in fluids. So it's the frictional force when an object moves through air or water. Friction of fluids. It's again, since it's friction, it's always in the opposite direction of motion. Also depends on speed. Since it's friction, more speed, more drag. Because more speed, more friction, more drag. Lower speed, less friction, less drag. Also depends on the nature of the fluid. Gas or liquid, it might differ in gas, it might differ in liquids, and the size of the object. So air resistance is going upwards because the direction of motion of the person in the parachute is downward due to gravity. Resultant forces. Resultant forces is a single force, one single force that describes all the forces acting on the object. So an object, for example a car, it has gravitational force pulling it downward, it has thrust moving it forward, it has friction moving backward, it has many forces on it, and the resultant tells us or describes all these forces. It's also known as the net force. A single resultant force can mainly determine the direction an object moves as a result of all of these forces acting on it and the magnitude. We have two types of resultant forces. The first one is a balanced force. Balanced force means when the two forces that are acting on an object are acting equally upon the object and they cause them to cancel each other out. So a car that has a thrust forward of 600 Newton and a frictional force backward of 600 Newton, since forward and backward are opposite to each other and they're both respectively equal, they will cancel each other out here, leaving you with no resultant force on the body. And in this case, on a moving object, the object will not accelerate, it will continue to move at a constant speed, because an object will accelerate, like we said, if the forward force is greater, and decelerate if the backward force is greater. But here, both forward and backward forces are equal, so there's net zero force and the object is not going to accelerate. On a stationary object, the object will just remain at rest. The second type of resultant force is the unbalanced force, where forces, again, it's unbalanced, there's no balance. So forces do not combine equally. They combine unequally, and they do not cancel each other out. They go to the bigger force side. Person A is pulling with 80 newtons. Person B is pulling with 100 newtons. 100 is obviously greater than 80, so the resultant is towards person B. How do we calculate resultant forces? The rule is very simple. Add forces in the same direction, subtract forces in the opposite direction. So if you have as you can see here, the first one, 5 Newton to the left, 5 Newton to the right, respectively equal, cancel each other out, balance, no resultant force. The second one, 3 Newton and 7 Newton to both to the right. Same direction, add them, resultant 10. 7 here, 3 there. The greater one is 7 minus them, 7 minus 3. Resultant is 4 Newton to the greater side, which is to the left. Newton's first law of motion. Newton's first law of motion states that an object at rest will remain at rest and an object in motion will continue moving at a constant velocity unless acted upon an external resultant force. So an object is at rest, it's going to stay at rest. Object is moving, it's going to keep moving unless a resultant force acts upon it. If this resultant force is zero, then, is not zero, then both speed and direction, which is the velocity of an object, will change. If it is zero, it's going to remain at rest, or it's going to continue moving at a constant velocity. To make an object change in motion, a force should be applied to the object. So Newton's first law of motion is very, very simple, and we experience it every day in our lives because you cannot make an object change motion unless you don't apply force to it. And you cannot make an object accelerate or deaccelerate that's already in motion unless you apply force to it. So an object at rest will remain at rest. Object in motion will remain at constant velocity unless you or some other internal or external factor causes a resultant force upon it. It's also related to inertia, which is the opposition of an object to change its velocity. So it's the opposition of an object to change its velocity, the resistance of an object to change its velocity. If you have a larger mass, it's harder to move heavy objects. So a refrigerator and a water bottle. A water bottle has less resistance to change its velocity to make it move because it has a lower mass, so it's easier to move it. A refrigerator has a larger mass, so it's harder to move it. So it has more resistance. It's resisting more when you're trying to push the refrigerator. But when you're trying to push the water bottle, it doesn't have much mass, so there's less resistance. It's not going to resist your push forcing or pull forcing. Adding forces on graphs and angles. So if the graph is going from left bottom to right front, and the resultant is going to be a plus b, which gives you c. Inverse it, you're going to get a plus b, which is c. Here is north of east, north of west. Flip it down, a plus b will still give you c, but it's south of west. Inverse it, south of east. Mass and weight. This is actually one of my favorite topics in physics because this is the one where 99.9% of us, especially unprofessionals in physics, or even some professionals in physics, during normal conversations, they make a lot of errors when talking about mass and weight. Mass and weight are not the same thing. And for sure, weight is not mass. Let's understand the difference and try to make it clear for all of us. Mass is a measure of the amount of matter in an object at rest relative to the observer. Weight is a force. It's a force. Okay? Weight is, in simple terms, the gravitational force. That's it. Weight is the gravitational force on an object. Or you want to define it, it's the force acting on an object due to gravitational attraction, which is the gravitational force. Weight acts on objects with a mass, because a force acts on an object that is made of matter. Mass is a measure of amount of matter in an object. So if weight acts on an object with matter, and an object with matter has mass. Mass is measured in kilograms, it's a scalar quantity. Mass is independent of weight or gravity. Weight is also known as gravity or the gravitational force. The greater the mass, the greater or harder it is to speed up, slow down, or move an object. Weight, on the other hand, is measured in Newton as a vector quantity. What we do, we usually say that your weight is XYZ kilograms, when actually kilograms is for mass. So if you want to say your weight is something, use newtons. Or if you want to say your weight is kilograms, just use mass. But weight and mass are not the same thing. When we say my weight is 70 kilograms or 65 or 50 kilograms, it's actually your mass you're talking about. If you want to find your weight through your mass, you can use the formula which we're going to learn in a bit. Object of 1 kilogram has a weight of 9.8 Newton, but we usually use 10 Newton in our exams because Earth pulls with a force of 9.8 Newton, approximately 10 Newton. So an object of same mass, 5 kilogram ball and 1 kilogram ball, both are going to fall at the same rate, 10 Newton, because Earth pulls at all objects with the same weight. Now, weight changes so depending on the planet and the gravitational attraction, but mass remains the same because the amount of matter in you will remain the same, but how much you're being pulled at by your planet, that differs. Gravitational field strength, which is also known as acceleration of free fall or acceleration due to gravity, is the acceleration and force per unit mass acting on an object falling freely under gravity in a gravitational field. The value of g, again, like I said, the value of g, which is weight, differs from planet to planet. So mass is constant, but weight differs on different planets. To calculate weight, weight is equal to mg, weight is equal to mass times gravitational field, where weight is in newtons, mass is in kilograms, and gravitational field is in newtons times kilograms. So when you tell someone your weight is 10 kilograms, your mass is 10 kilograms, and your weight is going to be 10 times the gravitational field, which is also 10, so your mass is going to be 100. Sorry, weight is going to be 100. If you want to calculate g using this, you can weight is equal to w over m, and if you want to calculate mass, it's equal to w over g. That covers everything under Newton's first law of motion. Now coming to Newton's second law of motion. Newton's second law of motion tells us that an acceleration of an object is directly proportional to the resultant force acting on it and inversely to the object's mass. So more force, more acceleration, directly proportional, more mass, smaller acceleration, inversely proportional. That's Newton's second law. So this means if you understand these two concepts, this one and this one, if you double an object mass, it's going to halve the acceleration of an object. To calculate Newton's second law of motion, the first formula is force is equal to ma. Force is equal to mass times acceleration. Where force is in newtons, mass is in kilograms, acceleration is in meter per second square. You can use the formula triangle to readjust the formula to find mass and acceleration. Coming to free body diagrams, these are very important in our syllabus. And these are diagrams that show all the resultant forces acting on an object. Usually in the exams, they're going to ask you to draw these free body diagrams, most probably for reference, so it's not going to be needed for marks, but it's very important to help you understand the question. Let's go through some examples. X sitting on a seat. When you're sitting on a seat, the most common forces are weight and reaction force. Weight pulling you down, reaction pushing you back up. Pushing a trolley. If you're pushing at constant speed, applied force, of course, anywhere there is weight and reaction, so those are constant. But applied force and friction is equal. If the object is accelerating, applied force is greater than friction. And if it's deaccelerating, the backward force, friction is greater than the forward force, applied force. Object moving in an elevator, the reaction force, if you're moving up accelerating, is greater than weight. If you're moving down the elevator, weight is greater than the reaction force. If an object is suspended, you have tension force and weight. And if an object is falling in air, which is using drag, because drag is the friction force in the air, then weight is greater than drag. If an object is being pushed up an incline, you have, of course, weight, reaction force acting perpendicular to the surface, you have the velocity of an object, and since it's being pushed up the incline, the force applied or the forward force is going to be greater than the backward friction force. Object falling freely is just weight. Circular motion is a motion around a fixed point. You have a fixed point, you're circling around it. Motion around a fixed point. And during this, there's centripetal force acceleration, which is the net force in an object directed towards the center. So an object in circular motion, it's very important to understand that it has a constant speed with changing velocity. The speed is constant. The change in direction per unit time is constant. But changing velocity, because velocity is speed with direction and the direction is changing. So the velocity is changing, but the speed is the same. It's always perpendicular at right angles, to the center. So for example, examples of centripetal force is used in a rope to spin a mass. It's used the sun or planets orbiting the sun in centripetal force, or when a car bends on tires, the electrons revolving around the nucleus in electron energy level shells. The main thing circular motion depends on is the mass, the speed, and the radius of an object. So this is an object. This is the direction of speed of the motion. It's actually moving here. But because this is centripetal force, it pulls it towards the center. So this is the centripetal force and acceleration, both acting towards the center. But this is the direction of rotation. And the direction of motion is, of course, not the same as the centripetal force. The last part of our topic is free fall. To define all of what you see here, to define it very simply and easily, free fall is falling when weight is the only force acting on your object or on the object. There is no air resistance, it's just falling with weight only acting. So during free fall, we know what is a force? Weight is a force. If force is equal to mass times acceleration, because when you're falling, you have mass. When you're falling, you have mass because mass is the amount of matter in you. And you have acceleration while you're falling down. So you have a force. Force is mass times acceleration according to Newton's second law. But since weight is the only force, so we can say weight is equal to mass times acceleration. So mass times acceleration, the acceleration here is your g. So we can say A is equal to g. This is known as acceleration due gravity. So weight is equal to ma, weight is equal to mg. Weight is equal to mass times the gravitational field, where weight is the force, g is the acceleration. All free-flowing objects have the same gravitational acceleration directed downwards towards the center. If it is falling or thrown, falling it increases by rate g, thrown decreases by rate g. This is the graphs. So for a distance time graph, this is the constant speed and balanced forces. And if an object falls, this is the maximum height it reaches and returns back. Velocity time graphs goes from upward and downward. This is the maximum height it reaches. Falling in air, when an object moves in air, drag acts in the opposite direction. You're falling downwards, the direction of motion is downwards. Drag is acting upwards in the opposite direction because it's a frictional force. Terminal velocity is the maximum possible constant speed, not changing, reached by an object. The maximum possible constant speed reached by an object. Let's take an example to explain terminal velocity. Our example is about a skydiver performing skydiving by a parachute. So the skydiver will fall from rest. When he falls, he will initiate to increase acceleration. So his speed is going to increase. The air resistance, as he's speeding downwards, the air resistance is going to increase, causing the net force and acceleration to decrease. But since he's speeding up, the air resistance will keep increasing till the air resistance is equal to the weight of the person going downwards, and there's no net force acting because up and down cancel each other out. There's no resultant force acting, and this is when the object will form at constant terminal velocity. Now he's gonna open the parachute. Once he opens his parachute, the air resistance is much more than the weight of the object. The air resistance is much more. So now the net force is upwards. So the object will slow down. This is why when you open a parachute, you slow down till the air resistance comes down and equals the weight once again, and the object will reach a new terminal velocity. So start at the fall, you only have weight acting on you, then you have more air resistance. So A is greater than G, object will still speed up till the drag is equal to the weight, a resultant force is, or terminal velocity is reached. Then when you open the parachute, the drag is much greater and you slow down till drag becomes smaller and equals the weight and you reach a new terminal velocity. This is the graph representing free fall acceleration, where drag is equal to Fg, drag is weight is greater than Fg, parachute is open, you're slowing down. because drag is greater, and you reach a new terminal velocity by the end.